We are going to be looking at a couple of problems from section 5.4. These two problems go together, so we'll look at them together. And in these problems, we are asked to, first of all, in 13a, make a scatter plot for the data. And I've shown the data below in the table. And I need to get my pointer option going here while we're looking at that. And in here it says make a scatter plot of the data, and then what is a better fit, linear or logarithmic? Now this is my summary of these questions here. They're stated a little bit differently. But what we're going to do is we're going to look at our calculator here, and let me make this slightly bigger so that we can see it. Since we already know what problem we're working on, I can make it as big as I can so we can see what we're doing together. To make a scatter plot of this data, we first of all have to put the data into the calculator. So going to here, we're going to go into the Stat menu, and we are going to edit. And earlier I had cleared out list 1 and list 2, so I'll just use those. And I'll put my X values in list 1, and they are 1, 3, 5, 7, and 9. So those are my X values. And then moving over to the L2 column, my Y values are -2, 1, 3, 4, and 5. So we have those data values in the calculator. Now, if we want to make a scatter plot, we have to go to our Stat Plot menu, and that's right here in yellow. So I'm going to do second function and Y equals. And what we want to do is go into here, and we want to turn it on. And we can see that we already have the scatter plot icon highlighted. We already have L1 for the X list, and the Y list is L2, and we're using the little squares. Before I graph this, let's set up our window a minute here, okay? If we look at our X values that we had, these went from 1 to 9, and so it's nice to have something less than 1 like 0, and something bigger than 9 like 10, and a scale of 1 seems to be pretty good. For the Y values, we need something less than -2, so let's use, say, -3. And we need something bigger than 5, so let's just use 6. And a scale of 1 looks pretty good. Now we can make our scatter plot. And let me double check one thing. If I hit the Y equals menu, no, there's no graphs in there, or no functions in there. Let's hit graph, and now we can see the scatter plot. So we're done with part A, but the reason we did part A was to answer the question for part B. And in part B it says, which is a better fit, linear or logarithmic? And when we look at this, we can see that these little squares that we have here, they're almost linear, but not quite. There's a little bit of a bend to it. And so our answer for this is we're going to think that this is a better fit is going to be logarithmic. So let's see what we get here. So I'm going to say that my answer for this is logarithmic. And let me just circle that. That's my answer for part B. Continuing on now to problem number 14, we're going to take the same data that we just entered into the calculator, and we want to find a logarithmic model. Well, once the data is in the calculator, it's not such a hard task to do. So looking at the calculator here, if I can find, here I am. If I hit Stat, and I want to go to Calc, and we are going to go down, and the first one that we want to find is a logarithmic model. And so that's number 9 here. So this is the LN that we're going to use, the logarithmic model. And our X values are in list 1, so I'm going to tell the calculator that my X values are in list 1, and comma, my Y values are in list 2. When we hit enter, we get an answer here. And our answer for this one, if I can get my cursor to right here, my answer is going to be Y is equal to the A number, which we see as -2.161. And then we have plus, the B number here is 3.182. I have to round it up to 183. And then this is times the natural logarithm of X. And so this is the logarithmic model that we'll get for this function, or for this set of data. One other thing that I'm going to note here while it's still on the calculator is that my r squared value for this one is equal to 0.9945, so that's 0.9945, and I'll refer to this later. Now it asks to find a linear model. So if I go back and go to the Stat menu, and again we want to calculate, but this time we want to use number 4 for a linear regression. And if I hit enter, and again I have to tell the calculator where the data is, so I hit second function, and I got to get that off the screen. Okay, disappear. Alright, hit number 1, comma, second function L2, and we'll hit enter. And we have a model this time, and this time we get a model of y is equal to a, which is 0.85, and if I want to keep 3 decimal places, I could put the 0 there, times the x, and then we have minus the b number, which is 2.05, and again, if you want to keep 3 decimal places, you can put the other 0. On this one, notice that our r squared value is equal to 0.938 about. Now, earlier in number 13, we said that the logarithmic was appeared to be a better model than the linear, and we can see that our r squared value here is closer to 1 than this r squared value, and so that tells us the same thing. They did ask us to do one other thing here and visually determine which is the better model, and we already did that for part 13, or problem number 13, but we're going to make it even better here. We're going to put these two in the calculator. So if I put the first one in, I have negative 2.161, and then we have plus 3.183 times the natural logarithm of x, and that's our first logarithmic function. And then the linear function, we had y equals 0.85x minus 2.05. Now let's graph these two models along with the original data. This is the logarithmic one, and we can see that this curve goes pretty close to all these, and so visually we can see that the logarithmic model appears to be a better model than the linear model. This then completes this particular exercise, looking at logarithmic models and then also comparing it to the linear model.